Hey there, welcome back to the Magic Box project. So in this video, I want to pick up where we left off. In the previous video, we were introduced to switches, and I gave a couple challenges. So just as a recapper, if you look on the whiteboard there, we have our circuit here that we designed, a schematic here. We have the Uno and the 5 volt with a resistor connected to an LED, and then the switch here. And we built this, and it does work. And let's just make sure. Let me plug in the USB for some power. Right, and let me go into the big view here. And I go like that. Switch on, switch off. Okay, so we got that working. If you don't remember how that works, you can check the previous video. Now let's go ahead and do the challenges. So the first one was a switch with 2 LEDs. So we want one switch that controls 2 LEDs. That should be pretty quick. Let's go ahead and do that together. Okay, so I'm gonna first just go ahead and build. You know what, maybe I'll just go do this. If you look at this one, my original schematic, right? So this schematic has one LED that's controlled by the switch. Now if I want 2 LEDs, just like before, I would just put my second LED in parallel. So I have another resistor and another LED, and I want to make sure that the plus goes to the resistor and the minus goes to the other connected to the other minus of the first LED. And now you have 2 LEDs in parallel, so whenever you turn on the switch, you're going to have electricity, half of it go through this way and the other half go through this way. All right, let's go ahead and build it just to make sure. It should be pretty straightforward, but always good to make sure. Okay, so let's go ahead and I'm going to leave this in there. So I need another resistor. I'm going to use the same type. I have the red stripe, so that's a 4.7K. I'm going to go ahead and grab my another 4.7K resistor. Here we go. And we know that one side of it goes into the 5V. I have these the 5V power rail here, so I'm just going to go ahead and stick it in there. Okay, maybe up here. That's good. Other side, just make a new row somewhere. Make sure nothing's in that row. Cool. Okay, and then my LED, I take another LED, and I know that the long leg needs to connect to that resistor leg, the new the one that created the new row, and the short leg goes where? If we look at our schematic, the short leg needs to connect to GND. Okay, well, I have GND. Is it GND? No. Let's look closely. It goes, the short leg connects to the same, the minus leg of the other LED, which is connected to the middle pin of the switch. Okay, so the middle, my switch is right here, okay, and then the middle pin is right there. So how am I going to stretch, right? I need to kind of do something like this where it stretches like that. Maybe I can reach. Let's see if I can do it. Let's see. So I'm going to do the splits here. Stretch it out. So this is the long leg, goes into the resistor row, my new resistor, and then the short leg into there, and I think I got it. So the short leg is into the middle, connected to the middle pin. I think I got it. All right, let's see. Let's plug this in. It's off right now, and then switch. All right, 2 lights in parallel. It is working. Cool. Unplug that. Let's go on to the next challenge. Okay, so now I need, looking at the whiteboard here, a switch and a button. So a switch and a button. and it controls just one LED in a OR circuit or circuit configuration. So OR means either the switch or the button can turn on the light. Okay, either one. You don't have to have both of them on, just either one, OR circuit. All right, so let's think about that. Let's go ahead and do some design here. Okay, we'll start easy. We know that we need a Uno, right? So let's draw that. We know that we need a 5 volts, so let's draw that. Okay, and just one LED, right? So we know that we need a resistor for the LED, and then we know the plus and minus connections, right? All right. Now the plus goes to the resistor. Now the minus, in order to have an OR circuit, we need a button and also a switch. So let's put the switch in first. Kind of just doing this off the cuff, right? We'll see what happens. Okay. Now I'm going to connect. The minus needs to go. Let's say it goes. I think we always connect it to the middle. That's what we did before. And then one of the outside legs here, I'll connect to G and D. Okay. Okay. So this is actually what we had before, right? And so in this situation, if the switch is switched in this position, right, then electricity can flow through the LED, come through the middle here, and then jump over because the switch here makes a connection between the middle leg and this leg here. And then if we open the switch, meaning we switch it over here, slide it over here, we have an open circuit. No electricity can get from the middle to the outside pin here to G and D, so there's no complete circuit. So that we've done before. It works. Now how do we add a button? So with the parallel, or I kind of gave it away, with the OR circuit, we want the switches in parallel because we want it to have the option, right? So either the switch can complete the circuit, or we can have a button to complete the circuit. So anytime we see here OR, we got to think something's in parallel. And what does that mean? So when something's in parallel, it means that the connections to the ends are to the same spot. So let's add a button here. If you remember how the button works, ours has 4 legs. The top legs are connected, the bottom legs are connected. And when I say the same spot, right? So I have 2 connections on the switch. I have 2 connections on the button, right? So I do have, it's 4 legs, but really 2 connections because the top 2 legs are connected and the bottom 2 legs are connected. So let's go ahead and connect the top legs to the middle button pin, which is also connected to, the middle switch pin, which is also connected to the minus of the LED. And then let's take the bottom legs and connect it to G and D. Okay, so once we have that, when we press the button, that means the top and the bottom, I'll draw a little dash line here as a reminder. Okay, when we press the button, the top and the bottom become connected. And if that's the case, we're going to have electricity flow down through here from 5V all the way to G and D. So we're good, right? And if you don't press the button, then it's going to go down here. If it's not pressed and top is not connected to bottom, it gets stuck, it's not on. Okay, so that works. And then also you have this other path that we talked about, the switch, that also allows electricity to flow or not flow. And so we should have a working OR circuit controlled by button and switch. So let's go ahead and build this and see what happens here. Okay, so let's go zoom in here so you can see on my little little screen there, my little whiteboard there. Okay. I don't like all the complexity here, so I'm going to take off the additional light that I did. I think, there we go. Okay. Now this, what I have here, is the switch with the light. So we've already done that. Let's just make sure it works. Okay, it's already switched on, off. Okay, cool. Now let's add the button. Okay, so let's take our 4-pin button. Okay, and let's see if we can do this with the least amount of wires. We'll see. Okay, so the top leg of the button needs to be connected. If we look at our chart here, the schematic, the top leg needs to be connected to the middle leg of the switch. So maybe I could just, the middle leg of the switch is kind of hard for you to see, but it's in pin 10. Okay. So what if I did this? Oh yeah, this could work. See, I just put my button right there. Okay. And it kind of works out perfectly. Let me wiggle it a little bit, get it in there. Okay, so my top legs are perfectly into the row 10, which is connected to the middle leg of the switch. Let me put this back. Okay, and then the bottom legs here are connected to nothing. So you see that? So that's good. It looks like it's connected to this brown wire, but it's not. The brown wire is one row above. Okay. So then now I just need to connect the bottom leg of the button, the bottom leg of the button to G and D. Is that right? Yeah, the bottom leg to G and D. Okay. So then I just get, let me get another, it's black wire for G and D is good, and I'll connect one side to the button. I'll go over here, and then remember my little tip, if it's kind of hard to go in, you can always turn it 90 degrees, and usually it's better. Okay, just kind of wiggle it. Don't be too rough, just wiggle, wiggle, turn, turn, and then we'll get it in there without breaking it. Okay, so then now that's in. Then the G and D ground rails here, so just plug it into any of these, like that. And I should have it complete and working. Let's try. Okay, I'm gonna plug this in. Okay, my switch is on. Let me switch it off. Cool. So the switch is off now. Let's press the button, see if it works. And that works too. Okay. I can use the switch to turn it on. Now, what happens if I turn on both? Is something bad going to happen? Well, if I turn on both, what's going to happen is that the electricity is, I'm looking at that little whiteboard there on the bottom right. The electricity is going to be able to go, it's going to have two optional paths. It's going to be able to go, see my yellow highlight? It's going to be able to go through the switch, or it can also go through the button, and it's all good. So either one is fine. So let's just try that out, make sure that works. So I can turn on the light with my switch and press the button. All good. And that's how OR circuit works, right? You can have either or you can have them both on, and it also works. Very cool. Now let's do the last one before we get to the exciting part, which is coding, okay? But first, let's look at the last challenge. Okay, we need a switch and a button controlling an LED, but in an AND configuration. AND. Okay, so AND works like this. The switch and the button need to be on in order for the thing to turn on. Okay, so let's go ahead and try that. Okay, let's do some design. All right, let's get that together. Okay, we have our Uno. We have 5V. Okay, this is all same as before. Our LED. Okay, now and means that you need both of them on, so you need things in sequence. Okay, the way I think about it is just, I don't know, I'm thinking of like trying to get through a series of gates or something, right? So let's say you're in a building and you're trying to get out, and there are multiple doors or gates, right? So you need to get, in order to get out of the building, you have to go through every single gate, okay? And so then that means you have a bunch of gates in a row or one after another, which means the same thing. We call it series, okay? So whenever you have an AND circuit, it means you have to go through everything or turn on everything for you to reach your goal. And so you have to put them in order, one after another. So that's all we do. So let's go ahead and do our switch first. So our switch here. Okay. And we like to connect the minus to the middle leg. Okay. All right. And then now we're not going to make the other connection for the outside leg yet, because we're going to put a button in series or right after it. So a button here, and we're going to put the top leg connected to the outside leg. Again, then the bottom leg will then connect to G and D. All right. So now you have the switch and the button not in parallel, but in series, one after another. Okay. So that means that if the switch is on, so let's say if we move the switch to the on position, okay, so that's like the first gate of trying to get out of the building. You're like, cool, okay, I got electricity going through here. It goes through and it's like on here. Okay, could go through the button here, or a switch here, and then go here. But if the button's not pressed, even though that this gate is open, that this switch is activated, because you can't get through the button, no good. Okay? So that's the correct situation in AND. And let's say that if you pushed the button, we have our little dash lines to remind us that when we press the button, the top and the bottom legs become connected. So let's say you push the button so that electricity could theoretically flow through there. That's cool. But if this is not activated, if this is off, what happens? You're like going through here, cool, okay, I'm gonna get to this side, but I can't because the switch is off. That's not gonna work either, because look, you have a broken yellow there. You don't have a complete circuit. Okay, so the only situation where you have the light turn on is if both of the switch and the button is activated, and that is an AND circuit. Sweet. Let's build this thing, and hopefully it will work right away. Okay, I have my AND circuit there. Okay, I'm gonna unplug. Okay, so let's see how we do this. So I'm gonna take the button off. Okay, I'm gonna take these extra wires out for now. Okay, so this is, let's see, I think I'm good here. So I have a resistor into the 5V, which is what we need. The plus of the LED is into connected to the resistor leg. The minus of the LED is in the middle leg of the switch, so that's good. And then what do we have next? So we're following, if you're looking on the whiteboard in the bottom right there, the top leg of the button goes to the outside leg of the switch. Okay, I think this is, so the outside leg, let me grab like a little pointer here. The outside leg would be, let me pull this out a little bit so you can see. Okay, the outside leg could either be the top one, like up here, or it could be the bottom one down here. It needs to be the outside leg. So I'll pick the bottom one down here because I have more room. So then I can just take my button and just put it in the same row as that bottom leg, like that. Yeah, it's a bottom leg now, not middle leg. Wiggle, wiggle. Okay, cool. So now the button is in series with the switch, and then what's the last connection? The bottom leg of the button needs to go to G and D, which that's easy, our blue ground rail, right? Okay, I'm taking this bottom leg, put my pin there, and wiggle, wiggle, okay? And then G and D. Cool. Let's try it. And circuit, one LED, one button. So let's see what happens if I press the button. Oh, so it works right now. I'm guessing because the switch is actually activated. So let's say if I turn off the switch, no good. So I have to turn on the switch and press the button for it to work, okay? So right now the switch is on, but no button, no good. The switch has to be on and the button. Cool. So we just did an AND circuit with the LED. We've learned about switches. We've learned about buttons. We learned about breadboarding. So we're doing great. The next step that we want to do now is I'm going to take a little time here to introduce coding. So far, if you remember, we'd had 4 parts of engineering here with engineering robotics. So one was the electrical. So we've been doing a lot of that with the electricity and the breadboards and all that. The other part was the mechanical, which we'll get to later. That's the body of the robot. But then the next part, which we're going to do today, is the computer, okay, which is the brain, and that's the Uno here, okay, and kind of how the connections here. So we've kind of done a little bit. We're good, but we're going to go to the next step with the computer engineering, and then fourth, we have the software engineering, which is the code, that will go into the Uno, which is going to be able to do cool stuff like control our lights. So right now we've only been able to control the lights by touching buttons or moving switches around or changing circuits on the breadboard. But today, by the end of today, we're going to be able to control the lights without touching it, because there's going to be code or software on the computer that will be doing that for us. All right, so first let's do a little bit of putting things together, okay? So I want to talk a little bit about the Uno. So in the Uno, I'm going to disconnect this. In the Uno, there are actually a bunch of switches. We've learned about switches, right? It turns things off and on. It makes connections. It makes the circuits either open circuit or closed circuit, which will turn off or on the lights. I wanted to introduce that to you because the Uno also has a bunch of switches. Okay, and then so let me draw that in there. All right, so we have our Uno. Okay, and then we have there's actually going to be a switch in here. It's kind of like, maybe I'm going to draw it like this. Okay, it's like our switch that we have, but it's rotated 90 degrees. Okay. And then we have one of the legs is actually connected to .5V, okay? Also inside it's 5V. So 5V, it has power, okay? And then the other leg here is going to be connected to a pin. So if you look closely, let me change here. I'm just going to disconnect this so we can focus on the Uno here. If you look at the Uno, if you look here, okay, it has 0, 1, 2, all the way up to 13, okay? Those are called pins, okay? I'm just going to call them pins. Pin 0, pin 1, all the way up to pin 13, okay? The pins there, those are like, I like to call them like little nerves from your brain. So remember the Uno here is like a brain, and our brain has little nerves that connect to throughout our body that allow us to control, like me moving this finger. Actually have like a nerve or a bunch of nerves controlling this finger. Okay, without the nerves, I can't move the finger. So it's the same thing here. Now, so the Uno has how many nerves? It goes 0 to 13. Think about it. So it's actually 14 nerves because it starts at 0. So 0 to 13. You have 14 nerves. So you'll be able to control like 14 lights, if that makes sense. You can control, connect a light to each nerve. And later on, we're going to play with, you can connect other stuff to the nerves as well. But today, we're just working with the lights. Okay, so this, going back to here on our drawing here. So the switch here is connected to a nerve, and we have 0 to 13. I'm just going to use number 7, lucky number 7 here. Okay, for the nerve. So how we're going to make a connection, sorry, let me go back to the big drawing, number 7 here. How we're going to make a connection is we're going to have an LED like this, right? We have the resistor as always, so it doesn't explode. And then connect that to the 7 nerve, and then connect the minus to G and D. That's it. So if we look here at the switch, we can kind of see what happens here, right? So let's say this part of the switch, I put an X here, is this leg's connected to nothing. So when the brain has the number 7, this has a switch like this, and that means that this resistor here is connected to nothing because the flow is like this, right? If you look at the flow is like this, okay? Then if I have the switch like this, the resistor here, the LED is connected to nothing, this X. There's no voltage, it's not going to turn on, okay? But if the switch is turned on like this, then what happens? Check it out. Now we have 5V power connected to here, connected to the LED, back to G and D, ground, the common ground we talked about that we need, and then the light turns on. So that's what's happening inside the Uno there. Now, what's going on here? What is controlling that switch? Is it your finger? No, it's actually it's the computer brain that's controlling it. And there's a lot more we could talk about, like how that's actually done, but it's actually that's what the computer does. Okay, it's electrical signals that are kind of kept in the computer, where it knows how to trigger and turns things on and off, so that it can turn on and off this number 7 nerve here. If you have more questions about that, feel free to contact me. We can talk more about that. I actually studied this kind of stuff. These are called processors, you know, how that actually works, how that brain actually turns on and off these little nerves here. But for now, we just want to know that it's a switch, and the switch is turned on and off by the computer, and the switch controls the light. So let's go ahead and build this, and then we can try to do some coding. Okay, so let's go here. All right, we got our thing here. Cool, we have our light. All right, I'm just gonna use this, super easy, because this LED has the resistor built in. So let's go ahead and use that. And then all we have to do then is, let's zoom in here so you can see. We have the minus needs to go to G and D. Okay, let me throw a minus in there, because I didn't do that. Put the minus is here, and the plus is there. Okay, so the minus goes to G and D, so I'm going to use a pin to socket wire, one of these. Okay, and let's do the black one to the black wire. Okay, and that goes to G and D. Okay, and then where's the red wire go? So the red wire has the resistor built in that we can see there, right there. And the red wire goes to nerve number 7 or pin number 7. I'm going to call it nerve today, but moving forward, I'm going to call it pin, okay? Because that's the more technical term. Nerve number 7. So I'm going to use, I'll go red, okay? Just to match the red here. And then just connect it to pin number 7 or nerve number 7, which is right here. Boom. That was easy. No breadboard. I don't want to do too much all at once. I'm just gonna keep the breadboard away. We'll go with this situation. Okay, and then now we just plug it in, and what do we see? Oh, it kind of popped on for a little bit, but turned off. So what we want to do now is we want to do some coding to control that light. Sweet. Okay, so let's go here. Let's go to the coding site. All right. So very exciting. Now we get to do coding. All right. So this is called the IDE. The IDE is where we're going to write all the code, and we're going to use the code here and send it via the USB cable to the brain. Okay. So let's go ahead and do that. I'm going to show you, go to here. You got to go to code.barnabasrobotics.com. Okay. And we're doing text coding today. So if you see it look like this, we're in the wrong mode. We're in block mode. We want to click on text code. So click text, and then it should look like this. If it doesn't look like this, you might have some stuff in it. Click new. Okay. And then this should come up. Okay, cool. So now we have two areas here. Okay. We have this void setup and then this void loop. Okay, we'll get into more about the technical terms here of these things, but for today, what I want you to know is that setup is something that runs only one time. So setup is kind of like what the word means. It sets it up. So once your computer wakes up, once the brain wakes up, it does whatever instructions are in setup, and it just does it right away and only one time. After that, it runs the instructions in loop. And loop does exactly what it sounds like. It just loops over and over and over again. Okay. So upon wake up, the Arduino computer does setup one time, and then it runs the loop, whatever is in the loop, forever. Now, right now, there's nothing in here in setup and loop, because look, like line 2 here, whatever's in between these little curly braces are the instructions. So there's curly braces here, no instructions. Curly braces here, no instructions. I got nothing going on. That's why it should do nothing, but let's try this. So I'm going to upload by clicking the upload right here. Okay. And once you do that, you're going to get your devices show up. Mine says USB serial COM4. If you're on a Chromebook, it might say USB TTY, something like that. So the device name will be different depending if you're on Mac, Chromebook, or Windows. But once that thing comes up, you click on it. You got to make sure you click on it, and then click connect. Okay, and click connect only once. If you click it several times, it's going to get messed up. Just click it once and be patient. So I clicked once, wait, and then I get this green check mark. You see that green check mark? The green check mark means that we successfully sent code from your computer to the computer Arduino here, and we're good. If you don't get the green check mark, then we got issues. Okay. So now it should be checkmarked, because if you click new, it sends you this empty code that should upload with no problems. Okay. If you have issues, then we might gotta check your cable, but maybe it wasn't connected. Sometimes you got a bad connection. You can try to unplug and plug it back in, that kind of thing. And if you get stuck, feel free to let me know, but it should be pretty straightforward. So once we got that set up, now let's write some code. Okay. So I'm gonna say, forget the setup stuff. Or actually, no, we do need the setup stuff. Sorry. Okay, so in the setup, we're gonna write. We're gonna go to line 2 and type pin mode. Okay, 7, comma, output, all caps, and then semicolon. All right. So let me talk about this a little bit. So first off, the pin mode command. What's up with that? Pin mode sets up the mode of the pin. Okay, so I talked about the nerves. The technical term is pin, right? So that's why it's pin, not nerve mode, because that's not a technical term. So pin mode is the command, and then you do parentheses. And which pin do you want to set up? Well, we connected to number 7, right? So we want to set up pin number 7, and then we do a comma because you're giving it 2 parameters, or two pieces of information. So the first one is like the nerve number or pin number 7. Then the second piece of information is output. Okay, so output means that we're going to be sending signals out of the Uno to turn on the lights. Okay, later we're going to use inputs too, where we're going to be taking signals into the brain, but this one's just out, so we have to say output. Okay, and then always ends, these statements are always going to end in a semicolon. So kind of like when you're writing a grammar in English, when you finish a sentence, you're going to put a period. Okay, so when you make a statement in this code, this is C code, you're going to put a semicolon after it. Okay, you don't always put a semicolon. In some cases, we'll get into that later, but for today, after the statement, you put a semicolon. The second thing I want to print out is the capitals and lowercase. So you see that the P here is lowercase and the M is capital. Okay, that's called camelCase. The reason you do that is that you have 2 words that are scrunched together. If you do it like this, you see that pin mode, you can tell right away it's not as easy to read. So what you want to do is you do the first letter of each word should be capital. Okay, now why don't we put the first one as capital? That I don't remember exactly why the convention is that way, but I think it looks better with the lowercase first, and then the rest of the words after that would be capital on the first letter. Like if it was pin mode, you would do it like this. Okay, but that isn't a command. Okay, so pin mode, we know camelCase, and then output, you see all caps here. Okay, now the thing I want to point out here is that the capital versus lowercase, it all matters. Okay, so for example, if I take this and I say upload, or you could also say, okay, let me talk about this, compile. Compile is it's doing a check on your code to make sure it's okay. So click compile, green check mark, cool. Okay, but what if that means your code checked out. But what if I change this to a capital P? Compile. See, error. Excuse me. If we look at it, it says row 2, pin mode was not declared in this scope. And you know, it's kind of talking computer speak. But what it means is pin mode doesn't work, doesn't exist, because it has to be lowercase. Okay, so when you click compile, so compile is good to check your code, make sure everything's good before you ascend it. And if you have errors, check your capitals and your lowercases. Okay, another one, if you don't have this semicolon, right, no semicolon, click compile, look, void error expected semicolon before token. So this one you can kind of like decipher, and that's another thing I'm doing right now. See, it says line 3. I want you to be able to read these error messages, because that's going to help you. It's called debug, or to troubleshoot your code. So you have the error and you're like, okay, line 3. Okay, line 3 is right here. Okay, but there's nothing here but this. But it's actually talking about the error was caught on line 3, but it's talking about line 2. So it may not be when it says the line right there. When it says this line here, it might not be exactly on that line, but it gives you a hint, like it's might be the line before, maybe the line after too. Okay, but because your code, we're gonna get really long, and so if you're not sure where the error is, it's kind of really hard to troubleshoot it, right? But if you look at the message, if you can decipher the message, it's gonna help you a lot. That's why I'm spending a little time on that right now. And it says expected semicolon, so that should give you a hint. Expected a semicolon, but there's nothing there. So that you like look at line 3, not there. Oh, line ahead. Oh, look, I forgot to put a semicolon there. Okay. All right. So the setup runs once. We set up the pin. Now in the loop, the part that runs over and over, I want to turn my light on. So digital right. Okay. Notice the camelCase, parenthesis, 7, comma, high. Okay. This takes the pin on number 7 and basically tells that brain in there, hey brain, make sure you turn the number 7 pin high, which also it's the same as on. Okay, high just means on. All right, so let's try this out. Upload. It's not gonna work, remember, until you upload. Click here, click this once, my LED, and I have a blue light on. Cool. So quick easy one, let's tell the brain to turn it off. Just go low, change it to low, remember, and notice it's all caps. All right, off. There we go. We just wrote code. Now that's not very interesting, right? All it's doing is turning, it's either off or on. Let's do something more exciting, right? Like let's make it blink. Okay, so how do we do that? Well, you need more than one command. So I have a low there. I can do a digital right 7 high. So what's that gonna do? I'm gonna first go low, then high. So off and then on, off and then on. And the way that this works, the loop works, I have line 6 turns it off, line 7 turns it on, and once I get to the end of the loop, it just goes back to the beginning and loops again. Okay, so it's gonna be low, high, low, high, low, high. All right, so let's go ahead and upload that and see if I can get some blinking going. All right, uploading, and I have it going. You can see, you can't tell that it's blinking, right? And so I always do this kind of as an introduction to the next thing that we need to keep in mind. This light, it looks like it's just blinking blue solid. It is, or not blinking, it just looks like it's just blue, right? It doesn't turn off at all. But actually, what's going on? It is turning off and on super, super fast, okay? You just can't quite see it, okay? So going back to the code here, we have low and then high, and then back to low because the whole loop thing, okay? Now, the cool thing about computers is that they're super, super, super fast, okay? So if you give it a command like turn off, it goes like that, like super fast. Then if you tell the next command like high, it does it like that, super, super fast. Like for us, you know, our brains work a lot slower in processing commands. Like doing math in our brain is a lot slower than like a calculator, right? A calculator is also a little computer that can crunch those numbers super fast. It's because it's not fair. They have a robot brain that's super fast. So if you want to know the actual number, I don't know if I have this correct. I have to double check, but I think the last time I looked, it's like a couple microseconds or something like that. So from line 6 to turn off and to turn it back on like that, the time in between doing off and on is like a couple microseconds, which is a microsecond is one millionth of a second. Okay, so super, super fast. So what you're seeing here, that's why I said this blue light's actually turning off and on super fast, but you can't tell because our eyes can't see that kind of flicker. So what we need to do is tell it to slow down, tell it to chill out. Okay, you're too fast for me. Sometimes it's nice, you want it super fast, like trying to do your math problem, but when you're trying to blink a light so that my human eye can see, you want to slow it down. So we add a new command. So after 6, do a new line here called delay, and I'm gonna put 1000 here. Okay, so that's gonna tell it to delay. Just means chill out, sleep. That's another way, or wait. Okay, it all means the same thing, but the command for the Arduino is delay. Now 1000 tells you how much you wanna wait for. So there's a unit there Like, is it 1,000 seconds, 1,000 microseconds, 1,000 milliseconds? You know, I'm gonna leave that open for now, and let's see if we can figure that out in a second. But first, we talk about the delay. So we put one right after the low. Okay, so that means once we turn it off, we want it to stay off for 1,000 milliseconds. Now we also have to tell it how long do we have to want it to stay high. Okay, so we turn it on, and we want it to stay on also for 1,000 milliseconds. Okay, so let's upload this, and we should have a blinking light. And we have a blinking light. Okay, so now that we're looking at this, what does 1,000... Oh, I think, you know what? I think I said it, right? The unit is milliseconds, right? Because this looks like about 1 second on, 1 second off. 1 second on, 1 second off. Okay? So if I wanted to make it longer, make it blink longer, I can change it to 2,000 milliseconds, which is the same as 2 seconds. Okay, let's make it slower. Okay, there we go. That's slow. And let's go fast, right? Like, what if I want to blink super fast? I can try 200 maybe. 200 milliseconds. And it should blink faster. Okay, uploaded. There we go. You can see that. Blinking a lot faster. Okay? So I'm going to write some challenges here for you. Have some fun. This green star / stuff is a comment, meaning I can put anything in here as just notes. So it's not going to be computer code. They're just notes. Okay, challenges. 1 is going to be see how fast you can get the light to blink. Okay, so you saw what I just did in changing the delay there. How would you change the numbers in order to make it blink even faster? And when I say how fast, I want you to kind of think. I want you to arrive at the number that allows the light to blink super fast, but not too fast where you can't see it. Because earlier I had no delay, right? It's essentially delay 0, but that didn't work because it's blinking, but you can't see it, so it's kind of useless. So I want it blinking super fast, but you can still see it. Like, what number delay would that give me? Okay, so that's one challenge. Now the next thing I want to do is go back here. I want to do this. Okay, I'm going to draw this and then I'll explain it. Okay, what is this? This up here is high. This down here is low. Okay, so, and then this here going this way. Let me fix this a little bit. There. This is time. Okay, so what this means is that I want one blink. This is one blink. This square here is one blink or a pulse. This other this is not a square, but this pulse here is another blink here. Okay, so I have a long blink, okay, because on this first one here, it blinks for longer, it's on longer, and it's off longer. But this second one, it blinks, it's on shorter, and then it goes off. Okay, so this is a long blink and a short blink. So I want I want it to do that. Okay, so let's do that together. I'm gonna go to our code here. So one long blink and one short blink. Okay, so let's see if I can pull this. Try to do a split screen here. Sorry, please bear with me. Just fixing the screen here. Okay, I guess I'll try to do it like this for now. All right, so the first thing is we start here. Okay, we start low, right? So we start low, and then right away we turn it high. So let's go to my code here. We start low, and then right away we turn high. Okay, and then what? And then we delay. It's a long blink, so let's say long is like 2000. Okay, so we wait here until 2000, and then what do? Then we turn it low. 7 low. Okay, and then we wait here again for 2000. So we keep it low here this time for 2000. So let me write, this is 2000. This is 2000 milliseconds. So after we turn it low here, we want to wait 2000 milliseconds. So another delay 2000 milliseconds. Okay. And then what? After that, we turn it back high. Digital write 7 high. Okay, and then we're here, but we only want to wait a little bit of time, so I'm going to say like 200 milliseconds, let's say. So I'm going to delay 200 milliseconds instead. And then what happens? Then we have to, once we get there, we have to turn it low right here. So we turn it low again. Digital write 7 low. Okay. And then let's say we just like, we turn it off, and let's wait. And we kind of want to wait a long time again. So kind of just going with our pattern though. Let's first wait at 200 milliseconds. Okay, because up here we did high 2000, low 2000. So let's do the same thing, high 200, low 200. And then let's do another wait here. Okay, another 2000. Okay. So you saw I did that. So what I should see when I upload this, I should see one long blink and then a boop, a short blink, and then it should repeat. All right, let's see how that works. Upload. Long. Short. Yep, it works. Okay, so I just showed you how we would do long blink and short blink. Now let's kind of clean this up a little bit. All right, so if you look at my code here, I don't really need this because high comes right after low. It's almost like the low didn't happen, you know. So I'm just gonna get rid of that, and then we have, you can kind of see a pattern here. So this is a long blink. So we look at our chart here. Okay, this is a long blink. These 4 commands is long. And then these this little blink here is also these 4 commands here. You go high, delay, low delay. So each 4 is one of these pulses or blinks. Okay? So here's your next challenge. I want you to make this pulse as the next challenge. Okay? So it's 2 long ones and 2 short ones. Okay? And then after that, I want you to do three long now I need to zoom out here a little bit. 3 long and 3 short. Okay? So first this one and then this one. All right, so I kind of gave you some hints, and then I'll in the next video I'll show you the answer. Now, just so you know, this here, this third one right here, is actually going to help you make Morse code for SOS. Okay, and I'll kind of, you can look into that, Google what SOS is in Morse code. So Morse code is what the military would use to send messages using blinking lights, or a telegraph using sounds like beep 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 beep, like that. So SOS is going to be this third one here. Okay, let's give it a shot. We'll talk more next time. That is it. All right, so have fun with that. If you have any questions, of course, always feel free to reach out. I will talk to you later.